So my lab studies how the growth of cells and tissues is regulated. We study cell growth both in human cell culture and in the fruit fly Drosophila, which is a model system that used to be used a lot in the past, but I think fewer and fewer labs are using the fly nowadays. And in human cell culture, we have a special technology called ribosome footprinting, which we use, which allows you to essentially see where ribosomes are in a cell as they are translating mRNAs. And that gives you a feeling for which mRNAs are being translated and the dynamics of the process. So we've pushed forward the ribosome footprinting technology to enable us to look at a phase of translation that is the key regulated step. So usually when a ribosome is recruited to an mRNA cap at the 5' end, it's just the 40S subunit. It scans the cap to look for a start codon, and then the 60S subunit joins, and then that's when translation of the protein or the production of the protein starts. And the traditional footprinting method allows you to only see the 80S ribosomes, and it missed all of the regulated steps at the beginning. So what we did was to develop a method to look at the scanning 40Ss, and this allows you to then look at a whole additional layer of regulation. What this discovery does, or let's say method development does, is to enable scientists who want to look at regulation of translation to access this phase of the translation cycle. I came to the FLI because I was invited by Helen Morrison, and this is because 5 or 6 years ago we started a new project on a disease called NF2, and Helen is a specialist and an expert on NF2, and so that's how we got to meet each other, and she invited me to come.